you know, I kind of, when I assigned that task, I was like, oh, I don't know if anyone's really going to get to this. It's the day before Christmas Eve. And in fact, really not a lot of people did. So we're going to have, but I am going to have you guys do that test. And again, even if you're not competing, it's just a chance to practice some problems. Okay. I'm going to have you guys do that next week. And then we're going to go over some of the solutions for sure next Saturday. So today, in celebration of the holidays, we're going to do a couple of things. One of them is about shopping, okay? Because shopping stuff always comes up in this. So let me ask you a question. Let's suppose it's Black Friday and you go to the store and you want to buy an item, and let's say it's $100, and there's a 5% sales tax. So you guys know what sales tax is? We don't have it here in Oregon. But it's basically, most states, if you go to the store and you buy anything, then you have to pay like 5% tax on the thing that you buy. Okay, so they don't do that here in Oregon. They just have income tax, which is where, you know, if you make $100, you have to pay, 5% tax on what you make. Most states, they do it as a sales tax. So here's my question for you. And I want to hear answers from you guys. I don't want me to be lecturing you. If I go to the store and it's Black Friday, and so they say something's on sale for 30% off, and it normally costs $100, but then I have to pay a 5% sales tax, how much am I going to wind up paying for that item?
Well, so quick clarification. Are you paying the sales tax on the original price or the discounted price?
So that's a great question, and the key to this. So one piece of knowledge that they assume you know is that sales tax you only pay on the cost that you actually pay. So they don't care if the thing was originally $200 and it's marked down to $5. Sales tax you only pay on the amount that the item that you're paying for the item. Okay. So who thinks that if something's 30% off, but then you have to pay 5% tax, who thinks you start with 100 and then you take $30 off, so that's down to 70, and then you put $5 back on because of the sales tax and you get to 75? Who thinks you have to pay 75?
No.
No, says Jonathan. What else do you guys think? Ethan, what do you no from Caitlin. Ethan, what do you think?
Well, it can't be 75 because you're adding 5% from the original cost, not the cost.
Exactly. So if it were to be 75, that would be 75. That would be $5 from the original cost. So in fact, what you would do, this would most likely be something that you would have your calculator for. So let's share screen. So whenever they have these like shopping problems, it's almost always not an addition. So in other words, you don't say, let's see, why is this not working? Still not working. Oh, because it wasn't plugged in all the way. It's almost never, okay, 100 minus 30 plus 5. Usually what it is, it's a multiplication. Now, the way that you solve this problem is you don't use 30 at all. Okay, what you use instead is, it's not the reciprocal, but it's 100 minus 30. Okay, so what you do is you say, well, 30 is what I save, but it's not what I pay. So if I'm saving 30%, what is the percentage that I'm paying? Not 30%, but what? What percent?
70.
70, because 100% minus 30% equals 70%. So what I'm really paying is 70%. So what I'm going to do is I'm going to take $100 and I'm going to multiply it by 70%. What's 70% in a fraction? I mean, sorry, in a decimal.
7, no.
It's 0.7, right? 70% is 0.7 written as a decimal.
Sorry,
Pardon?
sorry, never mind.
Okay. Then on top of that, you've got to add 5% sales tax. So if I have to add 5% sales tax, the best way to write that is 1.05. Okay? Because if I start with 100% and then I add another 5%, I get 105%, which written as a decimal is 1.05. Okay? Does everyone follow me so far? Okay. So most likely this would be given to you during part of the test where you have a calculator. And you would say 100 times point, you pull out your calculator, you'd say $100 times 0.7% times 1.05 equals 73.5%. Okay, 73.5%. Now, that's a pretty simple one. That might be like something that you would see early on in the test. But one thing that's a lot more common is, let me clear this, is to do something where they have multiple discounts. I see this all the time. So here's the problem. Okay, it's Black Friday. And for Black Friday, everything in the store is 30% off. Everything in the store, 30% off. But they say, if you come in before 11 a.m., you get an additional 20% off before 11 a.m. And back before COVID, this was super common because people wanted you to come to their store first because they figured if you come to their store first, you're going to buy their stuff and then just say, I'm not going to deal with these crowds anymore. This is too horrible. I'm just not going to do it. And then you go home. So they want you to come to their store first. So they'll give you an additional discount if you get there before 11. And then finally, what they sometimes say is, we'll give you a coupon for 10% off if you're one of the first 100 people to turn up. They really want you to get there early. First 100 people get an additional 10% off. And so MathCounts will ask you a question like this. They'll say, suppose that you have an item that's 70%, $75, okay? And you, because you know it's Black Friday, you're getting 30% off. And because you turn up before 11 a.m., you're going to get an additional 20% off. And because you're one of the first 100 people, you get an additional 10% off. How much do you pay for the what's your final price for the item? Don't include sales tax. Okay, so it might say something like that. Okay. So how are we going to solve this problem? First of all, can I do this? I know you guys have already answered this question, but can I say 30 plus 20 is 50 plus 10 is 60, so I'm taking 60% off? Does it work that way? How about
No.
Lucas? What? Jonathan, you say what?
Sorry, Lucas can go.
Go ahead, Lucas. What do you think? Can I do 30 plus 20 plus 10 equals 60, so I'm getting 60% off?
No.
I think I heard a no. And that makes sense because look, let me ask you this question. If I keep giving you, let's say 20% off, and I keep on doing 20% off for infinity, well, not for infinity, let's do it 100 times. Are you going to be paying $0? Or if there's something that's $100 and I'm going to give you 20% off and I'm going to do it 5 times, you're not going to pay $0 for that. Because the 20%, each of the subsequent 20% is not coming off $100, it's coming off of a lesser amount. Okay, so what are we going to do? We're going to do it just like last time. So if I'm taking 30% off I'm going to take this $75 and I'm going to multiply it by 30% off, but I don't really want 30% off because I don't want to deal with the 30 because that's what my discount is. I want to deal with how much I'm paying. So if it's 30% off, how much am I paying? What is the decimal that I'm going to write here? What do you think, Caitlin?
You would write 0.3.
Okay, so 0.3 is how much I'm discounting. So that's I'm glad you brought that up. So 30% is how much I'm saving, but it's not how much I'm paying. And in these problems, it's better to focus on what I'm paying.
0.7.
Excellent. Okay, and then likewise, if we take 20% off, we're going to multiply by point what, Jonathan? Not 0.2, but what?
0.8.
Good. And then let's see here, Ethan. If I want to take 10% off, what am I going to multiply by?
0.9.
0.9. Excellent. Okay. Now, if they give you this problem in a time when they have a calculator involved, that's fine. But a lot of times what's going to happen is they're going to give you this problem when there's no calculator involved. And in this case, if there's no calculator involved, I just want you to remember that most of the time you're better off not writing it as decimals, but as fractions. Let me give you an example of that, okay? So if you had a calculator, you go 75 times 0.7 times 0.8 times 0.9 and you'd be fine. But if they don't have a calculator, then the numbers that they're going to give you are going to be something more like this. They're probably going to say something like, instead of 30% off, they're going to say 1/3 off everything in the store just for showing up on Black Friday, plus 20% off before 11 a.m., plus 10% off for the first 100 people. Now, instead of writing these as decimals, if you don't have a calculator, most often, and this will be true for all kinds of problems, if you don't have a calculator, there's probably a trick that's going to make it easy. And the trick in these kind of problems is to not use decimals, but to use fractions instead. I'll show you why that's useful. So if I have 1/3 off, written as a fraction, how much am I paying? So before we'd say 1 minus 30% and we'd get 70%. But in this case, we're taking 1 minus 1/3 equals what's left as expressed as a fraction?
2/3.
2/3. Thank you. Now, what is 20% off, which is really 0.8? We already decided that, expressed as a fraction.
Eight over 10.
8 over 10. What's another way to write that that's easier? I mean, simplified.
4 over 5.
And then finally, 10% off is 0.9. That's 9/10, right? So why did I do it this way? I did it this way. I wrote these as fractions because I don't have a calculator and I can cancel. Okay. So let's look at the factorization of this. On the bottom, we have 3, 5, and 10. And 10 is, what are the factors of 10? Jonathan?
5 and 2.
Okay, great. So now I can do some canceling. I'm going to cancel this 2 with that 2. I have a 3, a 5, and a 5. What's 5 times 5? Lucas? 25. And then times 3 is 75. So I can cancel the 3 and the 5 and the 5. That equals 75. That can cancel this 75 right here. Now I haven't canceled the dollar sign. Remember last week we did like unit analysis. So the dollar sign hasn't gone away. I got to keep the dollar sign. And all I'm left with is 4 times 9 is 36. Okay. Now you could have gotten this answer the same way by using decimals, but without a calculator, it really is easier to use fractions in this situation. And you just got to know, if you see something that kind of has a hideous calculation involved, just think, are there any shortcuts I can take? If you don't have a calculator, if it's part of the test where you don't have a calculator, are there any shortcuts I can take? And a lot of times using a fraction will allow you to cancel. I mean, there's times when, you might have something like this. You might have these just enormous numbers that you're supposed to divide. Okay, so I don't know, some just enormous number on the top divided by some enormous number on the bottom. But if you can recognize that there's common factors, you don't have to do all the multiplying. You can save yourself a lot of time by just canceling. And we're going to talk about that a little bit later, because we're going to talk about how to know if numbers are divisible by other numbers. Okay, so we talked about that a couple of weeks ago, but we didn't finish that discussion. Okay, so I'm going to do one more problem with this idea of prices before we go on. And this is something that's important for you to know. Just as you know that sales tax you don't pay on the original price, they'll assume that you know that. They'll assume you pay sales tax on what the actual price is that you're paying. But one thing they may not assume, but I just want you to be introduced to the concept is that, does everyone know what a tip is? When you go out to dinner and you pay someone a tip, what is that?
That's like a little like a certain amount, like usually like 10 to 20% that you pay to like the waiter or like the person who's driving, and it's like a appreciation for their services.
Exactly. So it's usually 15, 20%, somewhere in there. And so they'll often have you calculate a tip. Okay. And there's a couple things to know about calculating tips. One is that although it's not necessary, the tip is something you do on your own. A lot of times if there's a discount on the meal, like let's say you bring in a coupon that's 50% off or buy one, get one free or something like that. It's not the server's fault that you brought in the coupon, right? They're not the ones who should take the hit for the fact that you brought in a coupon. So a lot of times, if you have a coupon for a meal, they will, it's polite to tip on the full amount. Now, MathCounts isn't going to assume that you know that, but they'll assume that you know what they mean if they say, for example, you have buy two $50 meals, $50 meals, and you have a 2-for-1 coupon, 2-for-1 coupon, and they'll say you want to give a 20% tip, but they'll say you're going to tip on the full amount, not the discounted amount, because that's not really fair to your server. The server's doing the same amount of work. They weren't the ones who issued the coupon saying, oh, please come in, let me be your waiter, I'll give you half off the tip. So they'll say you're going to tip on the full amount. So in this case, what you do is you say, I have 2 times $50. Now, let's say I have a 50% off coupon, but I don't have a calculator. So what am I going to do? I'm going to use a fraction, right? So what's 50% off expressed as a fraction?
1/2.
1/2. And then there's a 20% tip. So, and they're going to ask, what is the total bill? Now, if I have a 20% that I'm going to add on to the total bill, how do I express that as a fraction? First of all, let's talk about how to express it as a decimal. We did this before. Remember we said if we have a 5% sales tax, we express that as 1.05 as a decimal. Okay, because we have the total price plus 5% is 1.05. So if I have a 20% tip, how am I going to express that as a decimal? It's going to be 1, hey Morgan, What's a 20% tip and expressed as decimal? What do you say, Jonathan?
20% is 1/5.
Right, so that's how we would express it as a fraction. But let's do decimal first. How would you
Oh,
express
sorry, 0.20.
0.2? Okay. So as a fraction, adding a 20% tip is the same as putting 1.2. But we already said we don't have a calculator and we'd like to do it as a fraction. So what is 1.2 expressed as a fraction? First of all, let's say what is 20% expressed as a fraction? Lucas, what do you think? Or Ethan, you took it. Ethan, you off muted. What is 20% expected as a tip? I mean, sorry, expressed as a fraction.
1/5.
1/5. So what we're going to do is we're going to add 1 to that since we have to pay for our original thing, and we get 6/5, right? Did I do that right? So if I have a 20% tip, I'm going to express that as 6/5 because the original thing is going to be 5/5, and then we're going to add another 1/5 to it. So we get 6/5. So now I can do some canceling. I can go 2 cancels here, 2 cancels there. 5 cancels with that 5, and we're left with 10. So now I have the dollar sign keeps going. I didn't cancel the dollar sign, plus a 10 times a 1, which we can forget about, times 6 equals $60. That's our total bill. One thing you got to keep really on your toes here for these kinds of problems is read the problem carefully and see what they're asking. Sometimes they'll say, what's your total bill? Sometimes they'll say, how much did you save? Sometimes they'll say, how much is your tip? Okay, so you got to be super, super careful and make sure that the answer that you're giving them is the answer that they want. Okay, let's move on to something else. Okay, let's talk about divisibility rules. Okay, we've already done this a little bit. So remind me, let's just go down the list here. Jonathan, how do you know if something is divisible by 2?
If it's even.
If it's an even number. And another way to think of that is you look at the last digit, and if the last digit is divisible by 2, then the whole number is divisible by 2. So for example, 12, you could just say, I mean, you guys, this is so ingrained in you, you know that 12 is even. But another way of thinking about it is to say, what's the last digit? Last digit is 2, 2 is divisible by 2. Now, because even and odd is so ingrained in each of you guys, I'm not going to ask you to remember the whole last digit thing, but you'll see some similarities as we go to other things to see, you know, if it's divisible. You'll see that the last digit, it can often be really important. So something is divisible by 2 if its last number, if it's even. So we'll just say even. Okay. So Lucas, were you here the week? And if so, do you remember how we know if something is divisible by 3?
Don't you add up the digits and see if it's divisible?
Oh, I can barely hear you. Talk a little bit louder.
If you add up the digits and see if it's divisible by 3.
Perfect. So you are really faint, but I think what you said was you add up the digits, add digits, and if divisible by 3, I'll put a little divisible by 3, then the whole thing is divisible by 3. So again, 129, we say 1 plus 2 is 3 plus 9 is 12. 12 is divisible by 3, therefore it's divisible by 3. And if you have a super long number like this number here, you can say 1 plus 2 is 3, 3 plus 9 is 12, 12 plus 3 is 15, plus 6 is 21. And let's suppose you didn't know that 21 was divisible by 3. You could add 2 plus 1 together and you get 3. So you can do this multiple times. Hey, Jackson. Jackson, we're going over divisibility rules. So we've done 2 is even, 3 is you add the digits and see if they're divisible by 3. For 4, there's a couple of ways of doing that. One is to say, is the number even? That would mean it's divisible by 2. And since it's divisible, since 4 means it has to be divisible twice, you could divide the number by 2 and then see if the next number is also even. So if you, for example, if you had 104, you could divide that by 2 and get 52, and then this number's still even, so you know it's divisible by 4, but there's faster way most of the time. Okay. First of all, how many times does 4 go into 100? Morgan, what do you think? Okay, how about Jackson? How many times does 4 go into 100?
25.
Good.
Morgan said 25 too in the chat.
Oh, I'm sorry. Okay, one of these times I'm going to figure out how to show my chat. Oh, I think 25. Good. All right, fine. Okay, good.
And real quick.
Yeah.
Sorry I was late. Is there anything
That's okay.
I did miss things? What did I miss?
So you missed calculating values and calculating tips. So like if you have a discount of 20% plus another discount of 30%, how to calculate that. And I'll make so there's not a lot of people here, so I'll make a video and I'll send you guys the link this afternoon of and you can, if you like, you can watch the first part.
Okay, thanks.
Okay, so Morgan's right. 4 goes into 25. 4 goes into 125 times. So here's the thing, since 4 goes evenly into 100, if you have a number that's like this, we don't care about any digits but the last 2. And the reason is that suppose you drop these last 2 digits, what you're left with is 362,400. This number 00, if it ends in 00, is divisible by 100. And if it's divisible by 100, it's divisible by 4 because 4 goes into 100 an even number of times. So we don't need to worry about all these digits. All we need to worry about is the last 2 digits. So with any number, no matter how big, it is divisible by 4 if the last 2 digits are divisible by 4. So I'm just going to put last 2 digits divisible by 4. Okay, so that's kind of why I wanted you to guys at least consider this thing with even. Now you're always going to just, like I said, even is ingrained in you. You don't need to think about the last digit. You already know that. But what you're really doing when you say a number is even is you're looking at the last digit and see if it's divisible by 2. And in 4s, what you have to do is look at the last 2 digits and see if the last 2 digits are divisible by 4. Now here's kind of a harder one. 5 is easy, right? We've already discussed 5. How is something divisible by 5? Morgan, do you remember? Were you here when we talked about divisible by 5? And okay. You know what? And Morgan might be writing on the things, but I'm going to have Jonathan show me how to put, so, okay. Divisible by 5. If it's, let's see here. Let me go back to, okay, I've got to figure this out. Okay. So, Ethan, how do we know if a number is divisible by 5?
If the last digit is 5 or 0.
Okay, right. So let me erase this. And by the way, I've been working on a worksheet that's going to have all the things you need to know. I've been working on it. It's not ready to present to you, but I might give you a rough draft this afternoon. So last digit is digit 5 or 0. Good. How do I know something's divisible by 6? This is one that you could solve if you thought about it long enough. Jonathan, you might know the answer. You might have heard me say this before. How do you know if something's divisible by 6?
Well, one way you can think about it is that if the digits are divisible by 3, if the digits are divisible by 3, then if they're more, so they're divisible by 3 if they're even, or and if it ends with an even number, then it'd be divisible by 6, I think.
Perfect. Okay, so you're on the right track. By the way, I don't see my video. Is my video on? Okay. Right, you guys can see me, right? Okay.
Yeah.
Okay. So what Jonathan, I think, was trying to say, and I'm going to say it a little bit differently, is that any number that's divisible by 6 is also divisible by 2 and divisible by 3, because 6 is divisible by 2 and 3. So what we're going to say is, if a number is divisible by 6, if it's divisible by 2 and 3, not just 1, but 2 and 3. So all you need to do is run these two rules. So let's get a number 3, 6, 7, 2, 1, 4. Okay, I look at the last digit. The last digit's divisible by 2, therefore it's divisible by 2. I add up the digits. 3 and 6 is 9, plus 7 is 16, 18, 19, 23. Is 23 divisible by 3? No. Therefore, this number is not divisible by 6. Okay. Let's go to 7. 7's one of the trickier ones. Okay. And I actually have to look at my notes here for a second because I don't remember off the top of my head what. So give me just a second here. Okay, so something is divisible by 7 if, just want to make sure I get this right. The result of subtracting twice the last digit from the number remaining when the last digit is removed is divisible by 7. Okay, that's a hard way to, that's kind of hard. Let me get back to my whiteboard. So take the last digit. Let me put it this way, double the last digit. So double last digit. Subtract that by from the rest of the digits. From rest of digits. Okay, so let's do an example of that. Twice the last digit. Now, I'm actually not, let me just think about this for a second. So if I have a number that is 343, what I'm going to do is let me just check something really quick. Sorry about that. Okay. And then, so what I'm going to do is I'm going to say 343. I'm going to take off this last digit and I'm going to double it, and that equals 6. Then I'm going to take 34 minus 6 equals 28. Is 28 divisible by 7? Yes. So therefore, 343 is divisible by 7.
That's like super interesting, but also
I know,
I don't know why it works.
I don't know why it works either, and I'm going to have to think about this because okay, so here's the thing. I thought there was, I'll be honest with you, I just found this on the internet. I don't recall this being the rule. I think there might be a different way to find out. And so I'm going to look at this. I'm going to look this over this weekend. And if I find something, a different rule that I'm more used to using, then I'm going to teach you guys that one next time. But suppose you have this number that's really big, like 3, 6, 7, 2, 4, 1. So let's suppose we use this rule. So we take this number, we double it, and we get 2. Now we have to subtract it from the rest of these digits. 3, 6, 7, 2, and then 4 minus 2 is 2. Well, I still don't know if that number is divisible by 7, right? So now I'm going to have to repeat the process again. So let's take this number, let's double it, and we get 4. 3672 minus 4 is 366. And then the 2 minus 4 is 8 because I had to carry 1. So now it's 3668. Now I'm going to do the process again. I'm going to get rid of that. I'm going to multiply by 2 is 16. 366 minus 16 is 360. And still don't know because I don't happen to know if that's divisible by 7, although I'm pretty sure it's not. But I'll double this. I'll get 0, and I'll get 36 minus 0 is 36, and 36 is not divisible by 7. Okay. So, but I can tell that if this had been a 5, let me just put a 5 right here. That number would be divisible because then I'd do the exact same process. I'd get down to here and I get 35, which is divisible by 7. I'm going to pull out my calculator and I'm going to see if the number, see if we did this right. 357,241 divided by 7 equals, we did something wrong. Just let me try this one more time. 357,241 divided by 7 equals. Yeah, that's, I must have made a mistake in there someplace. Okay, we're going to forget 7s. I'm going to cover that next time. Okay, sorry about that. Because I just, you know, I've done this before. It's been, I haven't looked over this for, you know, 3 or 4 years. I know there's a rule for 7, and I just don't recall it being that. And so something's not right. So I'm going to look that over. Let's do 8. Okay. Remember how with the numbers 4, let me erase this. Remember how with the numbers 4 we said look at the last 2 numbers. We said look at the last 2 numbers like 3, 6, 4, 2, 0. We said just look at these last 2 numbers and see if those are divisible by 4. So there's 2 ways we can do this with number 8. One is we can say, is 8 divisible by 1,000? So 1,000 divided by 8. Now let's do this. Let's do 8 goes into 1, 1, 2, 3. 8 into 10 is 1 times 8 is 8, and that's 200. 8 goes into 200. 8 goes into 20 twice. 8, 2 times 8 is 16. Oops, I'm sorry. 2 times 8 is 16. Yeah, 160. 2 and then 2 times 8 is yeah. So two. Whether you followed or not my crazy math, because I do skip a lot of steps. 8 goes into 1,000. Okay, an even number of times. 8 goes into 1,000 125 times. Okay, sorry. So one thing you could do to figure out if something's divisible by 8 is you could say, are the last 3 digits divisible by 8?
Also, Dad,
Yeah.
can you just have been trying to figure, like, I just realized, because, like, 8, like, 1/8 that's a decimal equals 0.125.
Right. Yes. That's the better way to have done it. Sorry. So the other thing to do, the way that I prefer to do it is I don't like looking at the last 3 numbers. I think that's too much work. So here's what I do instead. So suppose we have this big number. When we look at the last 3 digits, the reason why we're doing that is that we're saying, okay, subtract off 241, and what we're left with is 36,000. And I know that anything that's divisible by, I know that anything that's divisible by 1,000 is divisible by 8. So that's why I'm able to drop off the 36,000. But that still seems like too much work to me. I also know that 200 is divisible by 8. Okay, 200 is divisible by 8. So what I personally like to do, rather than looking at the last 3 digits, is I say this. Okay, Yes, I'm going to get rid of these last, I'm going to only focus on the last 3 digits. So instead of 36241, I'm just going to focus on the 241. But I also know that 200 is divisible by 8. So if I can drop, if there's a 200, I'm going to drop the 200. If it's 441, I can drop the 400. If it's 541, I can subtract out 400 and be left with 141. Or if it's 800, let's say it's 841, I can get rid of the 800 because I know that 800 is divisible by 200 and 200 is divisible by 8. So I can get rid of that 8 and just use the 41. But you see what I'm doing here is I'm subtracting out groups of 200. I know that 200 is divisible by 8. So if I can take whatever my 3-digit number is at the end, let's say it's 360. If I can subtract out a 200, I'm going to do that. So I can subtract out a 200 from 360 and I can get 160. Okay. And then I can say, is 160 divisible by 8? And yes, it is, because 8 goes into 16 twice. And then I'm left, bring down the 0 and I'm left with 20. Okay, so let's do a problem here and see if I want to get you guys to work through this with me. So if we have 3, 4, 2, 1, 6, okay, is this divisible by 8? So Jackson, what's the first thing I'm going to do? What are the first digits I'm going to focus on?
The last 3, 216.
216. Okay, good. Now, I could just try to figure out if 8 is divisible by 16, and it wouldn't be that hard. Okay, I could just divide 8 into 216. It'd be fine. But again, since 200 is divisible by 8, I can forget the 200 and just focus on the 16. Okay, so 16 is divisible by 8, so this whole number was divisible by 8. So I'm going to say, in addition to last divisible by 8, I'm going to add here and then subtract out groups of 200. Sorry, that's just, so I'm going to type this up so you'll have a cheat sheet that has this information in it. Okay, what about 9? So 9 is, if the sum of the digits is divisible by 9, then it's divisible by 9. So just like we did here, where we added up the digits to see if those digits are divisible by 3, 9 is super easy too. We just add up the digits and divide by 9. So we put this here, add, boy, my handwriting is getting worse as the day progresses. Add digits, divide by 9. Okay, so if I have 343, I do 3 plus 6, 3 plus 4 is 7, 7 plus 3 is 10, 10 is not divisible by 9, therefore 343 is not divisible by 9. 10 is pretty easy. Lucas, how do you know something's divisible by 10? How about Ethan? How about you, Ethan? How do you know if 10 is something's divisible by 10?
If the last number is 0.
Okay. And then 11, I think, is the last one we're going to do. 11 is this one's kind of fun. You alternatively add and subtract the digits. Okay. So if, for example, our number is 346,217, you say 3 plus 4 is 7, minus 6 is 1, plus 2 is 3, minus 1 is 2, plus 7 is 9. And then you see if that's divisible by 11. And since 11 doesn't go into 9, then you know it's not. Okay, so add, subtract digits. So I'm going to send you all this. I'm going to send this all to you. But the question is, what kind of stuff is this going to be useful as? So a lot of times, what they'll say is, let me see if I have an example of a problem. I thought I had an example of a problem someplace that uses some of that, where using these rules is really helpful. Let's see here. Give me just a second. I'll find a problem here. Okay. So let's try this problem. Suppose that you multiply the first 6 prime numbers, okay? And then the question states this. So it says, Chris multiplies the first 6 positive prime numbers together. How many zeros follow the last non-zero digit of the product? Okay, so you multiply those, you multiply those numbers together, those prime numbers together, and then you look and you see how many trailing zeros are there? How many zeros at the end of the number? So I'm going to read the problem again. Chris multiplies the first 6 prime numbers together. How many zeros follow the last non-zero digit of the product? Okay, so our prime numbers, what are our first 6 prime numbers? Someone shout them out here. Jackson, what are the first 6 prime numbers?
2, 3, 5, 7, 11, and 13.
Okay. So if I had a calculator, I would multiply these numbers out and I get 2 times 3 times 5 times 7 times 11 times 13. And I would get the following number. Okay. And the question states, how many zeros are at the end of the number after the last non-zero? So there's only 1 0 at the end of this number. So our answer is going to be 1. But they're not going to give you a problem like this in MathCounts on the part where you have your calculator. Guarantee it. They're just not. They want to know not can you multiply numbers together and then look at them to see how many zeros, trailing zeros there are. That's not their goal. They want to know, can you set up a problem in such a way that you don't have to do the calculation? So this problem would guaranteed not show up when there's a problem with a calculator. So here's where this comes into knowing how to know whether something's divisible by something else comes in really important. Okay. So in order for there to be any zeros at the end of this number, what does the number have to be divisible by? For there to be any zeros at the end of a number, it has to be divisible by 10, right? That makes sense to everyone, right?
Yeah.
Now, in order for there to be 2 zeros at the end of any number, it has to be divisible by 100, right? For it to be 3 zeros at the end, it has to be divisible by 1,000. So what we can do is we can look at these factors and we can say, how many of these factors can we multiply together to get a 10 or 100 or 1,000? And let's look at these. So 13 can't be multiplied by any of these numbers to equal something that ends in a 0. Neither can 11, neither can 7, neither can 3. But the 2 and the 5 can be multiplied together to get 10. That is the only number, those are the only two numbers that when multiplied together equals a 0. And we only have one set of those. So therefore there can only be one, this whole number, whatever this number is, I don't even need to calculate it out. We know that it can be divisible by 10 because we have a 2 and a 5 as a factor, but there's no way that it can have two zeros because there's not a way to use these other factors to come up with 100. Okay, so we know there's only going to be one 0 at the end. I didn't even need to multiply all these numbers out. All I needed to recognize is that in order for it to end in a 0, there has to be factors that multiply by each other to be a 10. Okay, now suppose I gave you a whole string of numbers. Suppose I gave you 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 times 13 times 14. And I said, how many trailing zeros are there? Let's do the same thing. Okay, well, we know we're going to get one trailing 0 here, right? Because it's multiplied by 10, there's going to be a trailing 0 there. What other groups of these numbers can I multiply together to get a trailing 0?
2 times 5.
You said 2 and 5?
Yeah.
Okay, so that's going to give me a trailing 0. I'm going to cross those out and I'm going to make another 10 over here because that's going to be another trailing 0. What else? Are there any of these other numbers that can multiply together? I'm going to do this. I'm going to make a 15 at the end. Okay. So now what I could do is I could factor this 12 and I could make 6 and 2 and factor this 15 and make 3 and 5. Okay. Now I could take this 5 and this 2 and multiply them together and get another 10. Okay. So I'm left with a 6 here and a 3 here. Are there any of these numbers together? And I'm get rid of this 15. And I'm not seeing anything else that will let me multiply together. So I'm just going to try something. I'm just going to multiply these numbers together and see if we've missed anything. Let's see here. I'm looking for something called a factorial. Ah, here it is. So this is the answer that I get when I multiply all those numbers together. I get 1, 3, 0, 7, 6, 7, 4, 3, 6, 8, 0, 0, 0. And guess what? I said that there was going to be 3 zeros at the end. That's pretty nifty, right? So without multiplying these numbers together and getting this enormous number, and there's none of us here who could multiply this many numbers together and not make a mistake. There's just no way. But by using factors and recognizing divisibility rules, we were able to realize that there was going to be 3 zeros at the end of that big long number, and we didn't ever have to multiply them together. Okay? So that's going to be it for today. I will, before next week, I will send you guys a list of some of these rules that I've been telling you. And I would say, have the rules with you when you do the practice test number 1, okay? Because why not? I mean, why not get used to using those? And then we'll have you sort of work towards memorizing before the real test if you decide to take it. Let's see here. I'm finally noticing, I'm getting the hang of this chat thing. So someone says, sorry, it's a bit late. So cool. All right. So guys, so before next week, I really would like for you to take the practice test number 1. I'll send you out an email sometime today. They'll have a repeat of those instructions on how to get there. Even if you're not planning on competing, take the test and just see how you do. And it'll give you practicing math problems. It's pretty cool. Jackson, were you able to talk to your teacher and find out if you can enroll as a class or if you have to enroll individually?
I'm pretty sure I'll have to enroll individually.
Okay, so you have till January 15th to do that. And then I know someone who's not on this is we have another Hedrick student who is interested in participating. He's going to have to enroll with his own school. All right, guys. So good to talk to you. And we will see you again next Saturday at 9 a.m. All right. Thanks for coming.
Bye. Thank you.
Thank you.